in this example, we're not going to have an identity. We're just going to simplify using identities that we already have. I want to try to write this with as few symbols as possible. And there's no end goal, so to speak. For this example, I just want to show what's possible. And the reason is that when we're demonstrating an identity, which we'll do in a later video, we're going to have a lot of steps involved, a lot of little sub-problems. We have to rearrange things, and we might need to narrow our focus on how do I rearrange this, and then zoom back out to the larger problem, try to decide what to focus on next, then zoom in on something, focus on one element of the equation, manipulate it, and then zoom back out. We'll have to go back and forth, and you'll see in a later video that process. But I want to focus for now just on how do you simplify? Like, what do you do? And I'm looking at this expression. There's kind of a lot of pieces going there. Got lots of sines and cosines. I have two fractions, but their denominators are different, so I can't just add the numerators. If I wanted to, and I'm going to talk a little bit about different approaches, and then I'll point out. But this way is probably going to be easiest. So, but if I wanted to, I could try to get a common denominator. Say multiply sine x on top and bottom on both of these, so I can get a common denominator, and that will allow me to add the two fractions together, and maybe that'll be good. You know what? Let's go ahead and try that. I was thinking that a different approach would be easier, but let's try this. So I need to distribute this, to this sign here onto both of these, and this sign here onto both of these, right? So back up a little bit. Okay, so um, sorry, changing the color here. So when I distribute this, I'm going to have sine squared x plus cosine x. Well, let's say sine x cosine x. All over. And you know what? I made a mistake. These should not be sine. These should be cosine. All right, that's fine. You know, with this kind of problem, with so many moving parts, that's going to happen occasionally, and you just got to keep at it. Don't get too discouraged if you have to backtrack, because that is going to happen when you are demonstrating identities. Just correct the error and move on. Okay, so plus this will be sine x cosine x minus cosine squared x, and this is all over sine x times cosine x, and this one is over sine x times cosine x. Okay, so now if I combine the two numerators together, I can combine like terms as I go. These two can be added together, right? So this is going to become sine squared x plus 2 sine x times cosine x minus cosine squared x. And I think I see what can be done with this in the next step. And if you ever play chess or checkers or any strategy game, you kind of have to try to think one or two steps ahead. You know, ideally 10 steps, of course, but try to think about what's possible, what might happen, what might not. And I'm looking at this numerator, and maybe you should pause the video and think for a second. What am I going to do? What is it that I think I see? Um, but you know, now that I'm looking at it again, I don't think that's going to work. I was thinking that I might factor the numerator, but that this minus sign here, this minus sign in front of the cosine squared, I think that's going to prevent me from factoring. Because I was in my head, I was thinking, oh, maybe this will be like a sine of x minus cosine of x in parentheses all squared, but no, that's not going to work. So I've kind of run into a dead end. It's, you know, I've combined it into a single fraction, so that's simpler. But there's now maybe more symbols. There's a lot going on. I've got things that are squared. This is not really better. So I'm not going to erase it, but I'm just going to say, you know what, this didn't really go the way I wanted, so I'm going to start over. I'll just write it down here. Sine x plus cosine x all over, I guess this one was cosine x. plus, and this was minus, yeah, sine x minus cosine x. Sine x minus cosine x, and that was all over sine x, I believe. Yeah, sine x, okay. So instead of trying to combine into a single fraction, that didn't work. That made things worse. I'm going to do the opposite and separate into more fractions. So just a quick side note, whenever you have something like 2/3 plus like 5/3, right? Because the denominators are the same, you can combine and make 7/3, right? But you can also reverse that. 7/3 is equal to 2/3 plus 5/3. If you want to separate them, you can. So here, I'm going to separate this fraction into two fractions. I'll have the first term, sine of x, over its own copy of cosine x, the denominator, plus another fraction, cosine x over cosine x. Okay, so let me get this out of the way here. So this will be sine x over cosine x plus cosine x over cosine x plus sine x over sine x. And you might see the benefit of doing this already. Minus cosine sine x over sine x. Yeah, so those are both just equal to 1. This guy's tangent and this guy's cotangent. So I kind of have tangent plus, well, 1 plus 1 would be 2, minus cotangent. And see, now that's simpler. I have fewer symbols. I've made it simpler. So that was the goal. That's what I wanted. And maybe there's a way to make it even simpler. Maybe, I'm not sure, but I've done something. I've gotten to where it's fewer symbols, it looks simpler. This just did not really work, but that's unavoidable. When you're trying to work these problems, you're going to go in the wrong direction from time to time, and that's totally fine. I explored an option, didn't work, try something else. Yeah, so that is that example.